Alright, you guys that laptop, no laptops right now.
Turn it.
Pay attention.
Show who it is.
Now, you focus on this. So here, this is no surprise to you, right? I mean, it's just a pulley. It's just a singular string. So of course, 1 kilogram, 1 kilogram, 10 newtons balance each other. So, by the way, Sasha, this is inspired by your question. So, how much tension is in the rope?
FG.
How much tension?
FG.
What's that? Well, tension, I want you to think about what's going on here, right? Right now, this one is a weight vector down of how much? 10 newtons.
Wait, how much was it?
Right? This is 1 kilo. These are each 1 kilogram.
Right.
So 10 newtons about. 10 newtons down. It's at equilibrium, which means the tension up has to be
10 newtons.
10 newtons. That's it. It's 10 newtons. Now, Eric, you may be bothered by the fact that there are 2 of them here. Let me take one off, and let me just hold it with my hand. Maybe that makes you feel better. 10 newtons down, 10 newtons up. Does it? So, but that's the thing. If you're okay with this, then this should not upset you. It's really just doing what my hand did. It's a 10 newton tension. In fact, one of the common ways you'll see a setup like this is they'll have this point attached to a wall, and they'll ask you what's the tension. And really what it comes down to is look at the end that you know, 10 newtons down, 10 newtons up, the tension is 10 newtons. Now another way you can see that is actually to put a scale on here. Now this is, you can zoom in on it if you want.
Oh, I got you.
This is a 10 newton scale. Do you see that the little tab is all the way up to the top? So this is showing you, in fact, the force required, which is the tension, is 10 newtons. And whether I hold it here, or whether I hold it at an angle, or whether I hold it over here, that doesn't change. Okay? So that's the first part. So don't get concerned. One of the questions they can give you that'll trick you, whether there's a force scale on here, John, whether there's a force scale on here, whether this is attached to a wall, whether someone's holding it by their hand, or whether another 10 newton mass, or 10 newton weight rather, is sitting on here, the tension in this in all cases is 10 newtons. You can look at the one and it'll tell you 10 down, 10 up. It has to be. Okay. Now, one of the questions that actually is a little bit harder is, what happens to the tension when you
What?
do this?
That's illegal.
You have to find the. Oh,
What
perfect.
happens to the tension when you do this?
You gotta like find the angle.
Now,
and stuff.
mathematically, 10 newtons down, right? 2 arms,
It's not 5.
and so 5. I mean, we could do this without the tilt here,
Oh.
but so it should be vertically 5 and 5, right? And it is. However, you might feel like something's not right here. Well, I'll give you 2 examples. One is use your 2 arms as these 2. If you hold a weight with your 1 arm, you feel it tugging down on you, and you have to provide the full weight, let's say 20-pound weight, in your 1 arm to hold it up. If you put a second hand on the weight, does it feel easier to hold?
Yeah.
Certainly, because each arm now only has to support 10 pounds. So in fact, it is. Another way to show this actually is, so we'll take this one. Now, let's actually put one on this side too. So scales all around.
So many scales.
Too many scales, right? Okay, I'm trying. It'd be great if I don't drop this. Good. All right, so everything here, minus a little bouncing around, should say 10 newtons. Yes?
Let's see.
Little tabs are all the way up to the top, and these are 10 newton max. Now watch what happens during the process of transitioning from hooked on 1 to hooked on 2.
Whoa. Whoa.
You see it?
Whoa.
How much is each one showing? Roughly.
We don't need the VFX even.
Right? So each one is showing roughly 5. And so there it is. In fact, one of the questions that I'll give you on homework, which is a tough question, is explain this. Why is it now that it's gone down to 5? Now mathematically, you would say 2 ups balance 1 down, each one is half, fine. But what's actually happening here? What's happening here that's different from here?
there's an FG on that side.
Think about this, right? Can anybody think about it? When you bring this one over and it hooks in, isn't this one we're hooking it to relieving some of the effort of this rope?
3 times.
Well, you didn't
It's the
actually.
third
Well, you
time
didn't actually
John
say it, you
said
just
it.
whispered it to
You
yourself.
didn't actually say it.
If you said it
Yeah,
out
John, you
loud,
didn't actually.
It's
Go ahead,
the
John.
third time.
Points of contact. Like
Right.
there's 2 points of contact. So it takes some from the other one and puts it on.
You're bypassing the.
so it is helping the other side. In fact, each side is helping the other, and so there are only 5 newtons tension each. Good?
Yeah.
So beware, they sometimes like to give a question where this is a person sitting in a bucket and the person is holding a string. We had an elevator question.
Oh,
like
we did.
that, where the person's holding the string. And, you know, the diagram looks some iteration
Sits in an elevator on some stuff.
of
Spider-Man.
That just seems like an extreme sport.
this.
What?
What an amazing picture.
Truth is, and they often cut out the top of the picture. They just show you something like this. Some iteration of this. And so
Standing in front of the picture.
what the person is doing, of course, is they are assisting themselves. They're assisting the normal. Without them, if I were to hold this instead, the normal force has to support them entirely. But this is, its own weight is in a sense undoing its own normal force. So this cuts down. Now, another scenario that's related to this is what happens if the person starts pulling. And not pulling at a constant velocity, but instead pulling with acceleration.
Ew.
Well, that's a different scale.
Yes, this one is a 50 Newton max, so
Whoa.
it will only go up a little bit on this one.
Now we're cooking with gas.
Yes.
I didn't know they made those.
I thought they only went up to like.
And this
10.
one looks like it's not.
They got high.
Believe it or not, these have calibration on them. You know how you calibrate them?
Press a button.
You literally move the scale up and down.
Oh, that's pretty sick. That's not.
But that's actually, it's smart because here I know this is 10 newtons. And so it set this to about 10 newtons. Okay, good. Now, if you're standing here, why I can't get that sort of accuracy. All right, if you're standing here and this is you, and you start pulling on the rope,
That's me.
or if it's somebody else over here starts pulling on the rope, if you're pulling it at a constant velocity, nothing should change. However, what if the thing pulling this end, whether it's you in the bucket or whether it's someone
More
else on the
tension.
side, what if they pull it so that you accelerate up?
More tension.
Yeah, right? Think about that. Because if this has to accelerate up, there must be a net force,
Positive.
which means the tension has to be what compared to the weight?
Greater.
And so let's see if you can see it move up just when I first pull it. Because then once I start pulling it, I have to relax so it doesn't hit the top. And then it'll go the other way. So at first, let's see.
Oh,
Did you see it?
I missed that. I missed that. You gotta give me you gotta give me a heads up.
You ready?
Yeah.
So watch here, and I'm just going to do, it's only going to happen
Alright.
over a few
I'm
inches.
just
here.
practicing.
Here we go.
It's a couple inches.
Did you see it?
Yeah.
Let me try to go. I'll give it a greater acceleration,
Yeah.
which will last for less time, but hopefully you will see this
Jump
move
up.
down relative to the scale. Did it?
It's supposed to move down.
Well, at first, when I accelerate this way,
Ooh.
it moves down. But then at
Right.
the top,
It even moves up.
I have to decelerate.
So it goes
And
down.
so the net force will be down on this, and so this actually should become less. So really what it should do is go from 10 to 15 to 5 to 10.
Is 50 at the top or the bottom of the scale?
Up here.
What do you think it is?
Yeah, John. What do you think?
Because
So-
you said it would go down.
Yeah, my mistake. So then it's upside down. So John, if this is 10, it should go to like here,
Yeah.
and then it'll drop to here.
Okay. That's why I was confused because I said the other way around.
Did you see it? Did it jump?
We know what he meant.
No, because Elliot would have.
And then on the way down, could you tell? Actually, if we really drop it, now I don't know if you can see it.
Oh no.
Maybe you get it in the video. If I drop it entirely, what should the scale say?
0.
Yeah.
If I drop it entirely, will there be any tension?
No.
Joe, you can film it?
Yeah.
All right, you ready?
Man, am I nothing to you?
Say when. Can
When?
you actually zoom in close enough?
Yeah.
Perfect.
Let me
Can I
turn it
use
a
my
little bit
phone?
more so you.
Actually, no, I can't see it.
I've been recording. Been recording since day one.
All right. Well, let's try it. 3, 2, 1.
And we've broken our.
Wait, perfect. I got slow mo.
Well, it's probably fine on there.
No, you cannot tell
So
anything.
that's too blurry on that.
It's so blurry.
We try it later.
It's like 10 frames.
Wait, something flew off. What? Where? Oh, never mind. That was gonna be fun.
After it, yeah. It's got loops on it. Yeah. Okay, good. You can have it.